Now let's just move on further towards the properties, and now we will discuss about the properties of a parallelogram, which is a quadrilateral. So we are discussing the properties that are related with the parallelogram. So let us suppose if I'm just performing an activity. Let us suppose if I do have a quadrilateral which is nothing but of this type, such that I'm cutting it along the diagonal AC. So I'm actually cutting this particular quadrilateral along the diagonal AC. So if you cut this particular quadrilateral along the diagonal AC, what figure you can obtain? We can obtain the figure which is nothing but of this type, in which we have a ADC triangle and we have ABC, which is another triangle. So it means that after cutting the particular quadrilateral along its diagonal, we have obtained, or we have the two triangles over here, such that these two triangles are actually equal, or we can say that they are congruent to each other. Means if we can place one triangle onto the other, so they are exactly of the same shape, they are exactly of the same size, so they are definitely congruent figures. So hence what we have obtained over here, that when we will cut any particular parallelogram, if we'll cut any particular parallelogram, so here we are only focusing on the parallelogram. So if I'm saying a quadrilateral, I'm just talking about a parallelogram over here. So we have taken this parallelogram ABCD, and I also cut it along its diagonal AC. So if I'm just saying quadrilateral, I'm just focusing on a parallelogram only. So this is the parallelogram that I have taken, and if I'll cut it along the diagonal, so I am getting these two triangles that are actually congruent to each other. They are actually congruent to each other. So let us suppose if I just have to prove this fact, that whether they are congruent to each other or not. So this leads us towards the theorem which says that a diagonal of a parallelogram divide it into two congruent triangles. So I just have to now prove that the diagonal of a parallelogram is dividing it into the two congruent triangles. So let's just verify this thing. First of all, let us suppose if I'm just taking a parallelogram over here. So this is nothing but my parallelogram. Just neglect the angles first. I'm just taking a simple parallelogram ABCD, and I'm just taking a diagonal over here as nothing but AC. Now I have to prove that these two triangles are actually congruent to each other. So let's just start with the given condition. So let us suppose if I'm just starting with given is nothing but a parallelogram A, B, C, D, such that AC is a diagonal. AC is a diagonal. Now further, what we have to prove over here? We have to prove that the triangle ADC and the triangle, let us suppose if I'm just specifying the congruent sign over here, I just have to prove that the two triangles are congruent. So I just have to prove that the triangle ADC is congruent to the triangle CBA. So I just have to prove that ADC is congruent to the triangle CBA. Now let's just start with this thing. First of all, let us suppose if I am just starting with the proof of this one, as I'm just talking about BC and AD. Since we know that since in parallelogram A, B, C, D, BC is parallel to AD and AC is a transversal. So first of all, we know about this thing that the sides of the parallelogram are actually parallel, means this side is actually parallel to this side. So if this side is parallel to this side, so we can say that this AC is nothing but a transversal. So if AC is a transversal, then what can we say about the different angles over here? So let us suppose if I'm just taking this angle as nothing but angle 1, I'm just taking this angle as angle 2, I'm taking this one as the angle 3, I'm taking this one as the angle 4. So what can we say about the different angles over here? So we can say that in a triangle ADC and triangle CBA and triangle CBA, what can we say over here? That first of all, angle 1 is equal to the angle 4. Why so? Because they are alternate interior angles, and alternate interior angles are formed in between the transversal AC. So as you can see, angle 1 is nothing but is equal to the angle 4. Furthermore, we can say that angle 2 is nothing but is equal to the angle 3. Again, the same reason, which is nothing but the alternate interior angles. They are alternate interior angles between the two parallels AB parallel to CD. So they are the alternate interior angles again between the two parallels. So hence angle 2 is equal to angle 3. Furthermore, we can say that, let us suppose this is the first, this one is the second, and this one is the third. And with the third condition, we can say that AC is equal to AC, which is nothing but a common side. This is nothing but a common side. So from these three conditions, what we can say that the triangle ADC is actually congruent to the triangle CBA by ASA congruency criteria. By ASA means angle side angle criteria. We can say that the two triangles are actually congruent to each other, and this is exactly what we have to prove over here, that if we are talking about a parallelogram, then the diagonal of a parallelogram divides it into two congruent triangles, and we already have proved this thing, that the two triangles that we are getting after dividing a particular parallelogram with the help of a diagonal, they are nothing but congruent triangles. So this is all about the property of the parallelogram.